sklearn cluster affinity propagation. Description: clustering algorithm based on message passing between data points. It iteratively calculates responsibilities and availabilities for each data point to determine cluster centers and assignments. Inputs: affinity matrix, a square matrix representing the similarity between data points. Preferences, a vector of preferences for each data point, indicating its likelihood of being a cluster center. Outputs: cluster centers, indices of data points selected as cluster centers. Cluster labels, labels assigned to each data point indicating its cluster membership. Steps: initialize responsibilities and availabilities to 0. Iteratively update responsibilities and availabilities based on messages passed between data points. Determine cluster centers based on the final availabilities. Assign data points to clusters based on the cluster centers. Metrics: silhouette coefficient measures the quality of clustering by evaluating how similar a data point is to its own cluster compared to other clusters. Kalinske-Haraba's index measures the ratio of between cluster variance to within cluster variance, with higher values indicating better clustering. Visualization plots: dendrogram visualizes the hierarchical structure of clusters, but not directly applicable to affinity propagation. Scatter plot with cluster labels visualizes the data points in 2D or 3D space, color-coded by cluster membership. Fine-tune parameters: damping factor controls the rate of convergence and stability of the algorithm. Maximum iterations sets the maximum number of iterations for the algorithm. Uncertainty methods: probabilistic clustering assigns probabilities to cluster memberships instead of hard assignments. Challenges and fixes: sensitive to initialization. Try different damping factors and preferences. Use multiple random initializations and select the best result. Computational complexity is O(n)(2)T. Use a smaller dataset or approximate affinity matrix. Consider alternative clustering algorithms for large datasets. Can be difficult to interpret results. Visualize results using dimensionality reduction techniques. Explore different clustering validation metrics.